Уважаемые коллеги, нам следует начать, потому что мы уже потеряли 17 минут. Итак, приказом Санкт-Петербургского государственного университета от 12 июля 2019 года... ну я уже это говорил, но я...
As chairman of the Dissertation Council at St. Petersburg University. So I will follow the official procedure quite closely, not to omit something important. So today we shall hear the presentation by Rabadanov, Kurban, Magomedovich, investigation of kinetic processes in nonlocal gas-discharge plasma, submitted for the degree of candidate of physics and mathematics, specialization 010408, plasma physics. According to the order of St. Petersburg University, dated the 12th of July 2019, me, Timofeyev Nikolai Alexandrovich, Doctor of Physics and Mathematics, Professor, Head of the Optics Department at St. Petersburg University, was appointed Chairman of this Dissertation Council. Let me introduce my fellow Council members. Igor Cheslavovich Mashik, Doctor of Physics and Mathematics, Professor, Head of Department of General Physics at St. Petersburg University, Razhansky Vladimir Alexandrovich, Doctor of Physics and Mathematics, Professor of St. Petersburg Polytechnic University of Peter the Great, and Smirnov Alexander Sergeyevich, Doctor of Physics and Mathematics, Professor of St. Petersburg Polytechnic University of Peter the Great. In the remote mode, we should have Doctor of Physics and Mathematics, Professor of Beijing University, Yungling Wang of China, well, we can see Dr. Wang. Can you hear us, Dr. Wang?
Yes. Yes, I can hear.
Oh, good.
What you said.
And also, well, we should have in a remote mode. We should have academic advisor, Dr. Kudravtsev, but so far he's not online. Some formal statements I have to make. According to the federal law, the 23rd of August 1996 on science and the state scientific and technical policy, St. Petersburg University has the right to award academic degrees independently. A corresponding order on the procedure for awarding academic degrees at St. Petersburg University, on the basis of which we are holding this session of the Council, was issued on the 1st of September 2016. In accordance with this order, a session of the Dissertation Council is duly constituted if at least two-thirds of the approved members of the Council are participating, but not less than 4 persons. Our Dissertation Council consists of 5 members. All the members are present, including Dr. Wang in the remote interactive mode. Let me set forth the following procedure of today's session with the total duration of no more than 2 hours. We shall start with the Chairman's summary report on the main content of documents submitted by the candidate and their compliance with the applicable regulations. A brief presentation by the applicant outlining the key points of his research, questions to the applicant and answers, speeches of all the members of the Dissertation Council with their reviews and statements of their opinions, questions and suggestions to the candidate, speech by the chairman and his review, answers of the applicant to questions and remarks made by members of the Dissertation Council, an open discussion, speeches of any attendees with a summary of their positions and or specific questions and suggestions to the candidate. To do that, before speaking, all the speakers are kindly requested to put their names on the registration sheet. That will be followed by the final answers of the applicant to questions asked, a speech by the academic advisor. I'll have to read his review, a 5-minute discussion before the open voting on awarding or not awarding the academic degree to the candidate. Open for that. At that stage, I shall ask everyone to leave the room. So the discussion shall be only among the board members. That will be followed by the open individual voting and counting the votes, and a decision of awarding or not awarding the degree shall be made. That shall be the closing remarks of the applicant. Before we start the official procedure, let me remind you to switch off your mobile phones. Thank you for your understanding. Let me also inform you that our meeting is being recorded and broadcast online at the university website, and the speeches are being simultaneously translated from Russian into English or from English into Russian. And let us begin the meeting with our first item, Chairman's summary report. The thesis by Rabadanov, Kurban, Magomedovich for the degree of candidate of physics and mathematics, Specialisation 010408, plasma physics, on the theme investigation of kinetic processes in non-local gas-discharge plasma was accepted for defense by the order of the Academic Secretary of St. Petersburg University on the 12th of July 2019, order number 7830/1. The Dissertation Council was appointed by the order of the Academic Secretary of St. Petersburg University on the 12th of July this year, and I have already introduced its members to you, dear colleagues and guests. The applicant submitted the following documents to the Academic Secretary of St. Petersburg University: an application to the Rector of St. Petersburg University, Professor Krobachev, on acceptance of the thesis for consideration and defense, submitted on the 3rd of April 2019. A review by the academic advisor Kudryavtseva Anatoly Anatolyevich, candidate of physics and mathematics, associate professor of the optics department, a list of 7 publications which set out the main scientific results of the thesis, including 7 publications in peer-reviewed scientific journals from the list approved by the Ministry of Education and Science, and 7 publications in journals indexed in scientometric databases, Web of Science and Scopus. A certificate on passing the candidate examination, dated 20th of March 2019, issued by St. Petersburg State University, stating that Rabadanov, Kurban, Magomedovich passed the candidate examination, Specialisation 010408, plasma physics, with the following results: history and philosophy of science, physical and mathematical sciences, good; English language, good; plasma physics, good. A diploma on completing the basic program of higher education, issued on the 10th of July 2015 in St. Petersburg University, certifying that Rabadanov, Kurban, Magomedovich was awarded the master's degree in physics by the decision of the Specialisation Committee on the 26th of June 2015. The thesis in Russian and English on paper, on the rights of manuscript, and in the electronic form. The thesis has been formatted in accordance with the requirements of state standard GAST R70, printed and multiplied with the output data according to the state standard. It should be noted that all the documents listed above comply with Clause 12, Section 3, thesis presentation and defense of the procedure for awarding academic degrees at St. Petersburg University. If anyone has any questions related to the documents, if no one has any questions, let's give the floor to the candidate. You have 15 minutes, please. Thank you for the introduction. Good afternoon, distinguished chairman, distinguished members of the Dissertation Council, distinguished guests. I would like to present my report on my thesis, Investigation of Kinetic Processes in Non-Local Gas-Discharge Plasma. The goals of this work are as follows: investigation of the influence of the ambipolar field on the formation of the electron energy distribution and other characteristics of the positive column plasma, clarification of conditions of applicability of local approximation for the solution of Boltzmann kinetic equation for electrons, develop an implementation of a technique for calculating non-local programs and codes to solve the local Boltzmann kinetic equation. Investigation of the influence of the electron-electron collisions on the formation of non-local EDFs and other kinetic characteristics of the positive column. Study of the influence of processes with the participation of metastable atoms on the formation of non-local EDFs and other characteristics of the positive column. The object of this study was a positive column of glow-discharge plasma in argon in a constant electric field in a cylindrical tube with a radius of 1 centimeter and medium and low pressure. For the study of this object, in the first case, in the case of studying the influence of bipolar field on the formation of EDF, the kinetic and drift diffusion modules were developed. To study the issues of non-local kinetics of electrons, a method based on the solution of Boltzmann non-local kinetic equation was developed. Both methods were implemented in the Cosmo Multiphysics numerical simulation software package. A total of 7 articles have been published on the theme, 7 peer-reviewed articles, and presented at international conferences. A model includes a number of related modules. To solve this problem, we developed a model that included a number of related modules in COMSOL multiphysics, a kinetic module for calculating two-dimensional EDFs, the first module for calculation of a two-dimensional function which solved this Boltzmann equation, which has the following form. The second model included the drift diffusion for calculation densities and Poisson equation. The third module included equations for calculation of the longitudinal field, which was calculated with the help of iterative procedure. We obtained the following results. On the left side, you can see the results of comparing the EDF at the pressure 3 torr. It can be seen that the EDF at different points is different. This mode corresponds to the non-local case when the condition is met. The right side shows the radial profile of the excitation rate constant at different pressures. It can be seen from the figure that with increase in pressure at the periphery, the excitation rates increase. This increase may occur due to additional heating of the fast electrons. Next slide shows the ratio of the ambipolar to the heating field at different pressures. The right part shows the length of the energy relaxation of electrons at different pressure values. This, as the figure shows, that the condition is fulfilled at high pressures up to 6 torr. However, these conditions, you can see the ambipolar field dominates the periphery of plasma, and if we make a simple assessment, it turns out that smallness of the polar field in comparison with the heating field. That is why this domination of influences electron properties, which was shown on previous slide, calculation of the non-local EDF with local Boltzmann solver. Currently, there's quite a number of package programs that can solve the Boltzmann local equation. However, at high and medium pressures is not met. Therefore, the inapplicability of local approximation for the leads to serious limitations for the use of these software packages. Holstein and Zendin propose an approach to find the non-local EDF, which is based on averaging the Boltzmann equation by the volume accessible to electrons with full energy. And in this local equation, averaging by G value in case of cylindrical geometry is fulfilled as follows, and the W coefficient has the following form. The other coefficients are also averaged, and in the final form, the averaged Boltzmann equation has the following form. It should also be noted that in order to average these coefficients, it's necessary to know the profile of the ambipolar potential. In this paper, we used the following profile. And the results were as follows. On the left side, you may see a non-local function from full energy and the potential profile used in our work. This figure shows the potential at point R, says the minimum total energy of the electron, where the kinetic energy is equal 0. And electrons with lower total energy are locked in the central region, cannot reach this point. And the EDF at point R is cut off, so that only part of it at point R represent EDF from the total energy. On the right side, there's a non-local EDF at different points of tube cross-section. It can be seen that the non-local function, in contrast to the local one, is different in different points of radius. As it can be seen, it can also be seen that a decrease in the non-local function starts from the excitation threshold energies. On the periphery, however, this decrease starts with energies lower than the excitation threshold. This is due to the fact that the boundary between the body and the tail of the function corresponds to the threshold of inelastic process, as in the local case. Therefore, we should note that at the periphery of plasma, the function decreases in those areas where inelastic collisions do not occur, where the kinetic energy is. Next slide shows the ratio of radial profile of excitation, rate constant, and the electron density to their values on the axis. It can be seen that if in a local case the profile doesn't depend on the radius, the profile of the non-local excitation rate depends on is noticeably compressed to the tube axis and decreases sharply towards the periphery. The picture on the right shows a radial profile of the mean energy of electrons. We have local profile under number 1, non-local profile under number 2, and the profile of the mean energy from the Einstein ratio. It can also be seen that if the average energy is constant over the entire radius, the radial profile of the non-local EDF decreases towards the periphery. Next point. how influence electron collisions. Modern software packages may take into account electron collisions. For this purpose, it's necessary to take into account the data of the collision member, which looks as follows, and to calculate the non-local function by the Hallstein-Zendin method. It's necessary to average the coefficients in the collision member. Since these coefficients include EDF itself under the sign of integrals, the average coefficients have not yet been obtained. Since these are coefficients under the sign of integrals, the averaged coefficients have not yet been obtained in the correct form. In our paper, we have obtained expressions for these averaged coefficients, which look as follows. The results are as follows. On the left, you may see comparison of the local, non-local functions, taking into account the electron-electron collisions and the Maxwell function. It can be seen from the figure that as the degree of ionization increases, the difference between the local and non-local functions decreases, and they tend to have the same limit, the equilibrium Maxwell. On the right, you may see the ratio, the radial profile of the ionization rate constant. It also shows that counting the electron collisions and with a low ionization, it drops abruptly when approaching the periphery. Yet, when a high degree of ionization grows, this effect can be explained by Maxwellization of the function with a common inclination as the energy changes. Next, we studied the influence of metastable atoms on the formation of non-local function. To take into account the processes involving metastable atoms, it's necessary to take into account the collision member, which has the following form. And in this case, the average collision member looks like this. Next, this collision member is inserted together with the other averaged coefficients, and the equation is solved. The results are as follows. The figure compares the local, non-local functions with the metastable atoms at different levels of excitation on the discharge axis. In this figure, we observe a little-known curious effect, which consists of a kind of a copying of the EDF body in its fast part due to blows of the second kind of electrons with metastable atoms, where the slow electrons acquire additional energy. And it can be seen a gentle stand copying the body of EDF. A slow part is added to the usual function, sharply decreasing beyond the excitation threshold. Next slide, on the left part, shows a comparison of non-local EDFs at different values of the given field. Taken into from this figure, one can see that at low fields there's a fast growth and then the same fast decline of the function tail. This can be explained by the fact that at low fields the electron receives little energy from the field, and due to the ultra-elastic shock, the electron receives additional energy, which it immediately loses when it collides with other heavy particles. That is why at low fields we observe sharp growth and decrease. On the figure on the right shows the rate constant, taking into account the metastable atoms at various degrees of excitation. It can also be seen the constant at different points of radius is of different importance, and that the inclusion of metastable atoms leads to strong differences. So we can draw the following conclusions. we studied the influence of the bipolar field on the formation of EDF, and the importance of taking into account the bipolar field for obtaining reliable results has been shown. We showed that for applicability of local approximation, it's necessary to perform not only the conditions of low energy relaxation length, but also the self-consistent bipolar field. The technique for calculation of non-local function by the method of High-Stein-Zending by means of common programs for the solution of the local Boltzmann equation has been offered and implemented. By the example of a positive column in argon, we showed that there is a significant difference between local and non-local EDF and other plasma characteristics, especially in the periphery of plasma. On the basis of proposed technique, the influence of electron collisions on plasma characteristics has been analyzed for the first time. The correct expressions for coefficients of inter-electronic collisions that can be inserted in the average Boltzmann kinetic equation were obtained. For the first time, the influence of the processes with the participation of metastable atoms on the formation of non-local function has been investigated. The important role of processes involved in metastable atoms in determining characteristics of plasma is shown. The effect of copying non-local function has been described, which has been detected earlier in a local phase. Thank you for your attention. Thank you. Questions? Can you please show the picture? Shows longitudinal fields and excitation speeds. Here, you may see that plasma can be divided in two areas. Ion plasma, where the longitudinal field is much bigger than ambipolar field, and the wall where ambipolar field is larger. But where's this drawing with the excitation speeds? Yes, here. Here, if you look at great pressure, take high pressure, see that ionization and excitation on the periphery occur on the periphery. And is there any we observe any ionization in the volume of plasma, in the entire volume of plasma, or does it happen only on the periphery? Thank you for your question, Oleg Borisovich. Yes, ionization occurs, but on the periphery, the excitation rate also increases. This should lead to the ring dislocation. And how does that relate to your experiments? So far, we have not been able to test that, but we plan to carry out such an experiment in the future and test this model, because our principal goal was to compare the EDFs, so we did not study this issue in detail in our work. Thank you. Does anyone else have questions? No more questions? Now let's hear the reviews. We don't have any external reviews. Is that right? No, we don't have any external reviews. We have not received any external reviews. So the first review, give the floor to our colleague from China, Professor Wang.
This dissertation. Do you hear me?
Yes.
Okay.
Yes.
Maybe my points, not wholly, but main points, remarks, and the.
Please read your review. Could you please read your review now?
Okay. Yeah, I think the work of
Я
Mr.
считаю,
Kurban
что работа господина Рабаданова.
Okay. Yeah, I think
Я считаю, что работа господина Рабаданова
Mr. Kurban is very interesting.
очень интересная.
He gave us many new results.
Мы
Okay, can I? Yeah, I have questions. Yeah. Yeah, I want to know how to set the boundary condition to resolve the non-local kinetic Boltzmann equation in software packages.
Have you some remarks on this?
Could you please ask your question again?
Professor, you have your remarks on this?
Yeah, I want to know how to set the boundary condition or the initial condition to resolve the non-local kinetic Boltzmann equations.
Ты понял?
Ну, первый вопрос, насколько я понял, был вопрос того, как это реализовался у нас в консоли, данный метод.
Курбан, давай так договоримся. Сначала вопросы, а потом ответы все в конце. Okay, your main conclusion, Professor Yunhilguan. Your main conclusion about this is?
Okay.
All answers will come in the end.
I think
Я считаю,
Mr. Kurban
господин
deserves to be granted with
Рабаданов
a degree of
заслуживает
physical
степени
mathematical
кандидата
science.
физико-математических наук.
You're welcome.
Профессор Смирнов, пожалуйста, ваш отзыв.
Professor Smirnov, can you please read your review? I will not read the whole review, or I'll go straight to the critical points. But the goal of the study, the aim of the study is highly relevant because today many gas-discharge models are being built, used in microelectronics and other spheres, other industries, and the conditions are always complicated. Gas mixtures are complicated, and getting analytical codes which can be used to calculate such complex conditions usually utilize the local approximation, which is most often used even in such fields where it's inapplicable. So it was very important to obtain some clarifications where locality is significant, and methods such as the Monte Carlo method for exact calculation of EDF and the kinetic process is not possible yet because you need too many particles for that and too much machine time. So the goal of the study was good, and the candidate achieved his goal and that would benefit. And as for the thesis itself, there's no compare, or the author does not compare distribution function with the experimentally measured. It's possible to should have found experimental data, at least for some calculation conditions. Such calculations have been performed by many researchers, including some researchers of your department. The thesis doesn't say which border conditions were used to solve the Boltzmann kinetic equation, and the additional non-locality criteria could be better described as a relation of the length of relaxation to the potential change length. So then both criteria would look similar. Yet the candidate will answer all the questions in the end, and so the work is well written and meets all the requirements applied to a candidate's thesis, a candidate of physics and mathematics. Thank you, Alexander Sergeyevich. Dr. Rozhansky, please. I will give a brief summary of my review. The main goal of the work, numerical modeling of gas discharge, taking into account the non-local effect of radial electric fields, is very relevant and also very complicated. And what the author has achieved deserves attention, especially considering results achieved with non-local approximation, and a very challenging task has been solved. So this work is important, and this has been some contribution significant contribution to our understanding. And as for my critical comments, in reality, is the potential, which is a key player, has not been calculated in the thesis. Which would be too difficult. The author uses some approximation, and this potential he used in his calculations. So the question remains open. Comparing with the experiments, this was my second comment, which has already been mentioned. And for me personally, it will be interesting to see the results assessed as how they affect the transition, how transition coefficient is affected. There are some mistakes, grammar mistakes, and spelling mistakes, punctuation mistakes. But on the whole, I think the thesis is good, and the candidate deserves the degree of candidate of physics and mathematics. Thank you, Dr. Shansky. Dear colleagues, my review has also been positive. I agree with my colleagues, and well, the task was challenging. The work is relevant and valuable, and I have very few comments in relation to what the author has done. Maybe there's one point I'd like to make. When we talk about creating an instrument to study such objects, so you instruct future researchers of what they should measure. So it will be interesting to see how how sustainable your solutions are, and maybe it's not sustainable. Have you ever tried to change the parameters you entered? So maybe you is it true or not? Maybe the parameters will change. There is so that's something I am concerned with. But in general, the work is quite well written, and speaking of achievements of the author, I think the thesis meets the requirements. And this meets the requirements, and the author deserves to be awarded a degree of candidate of physics and mathematics, specialty plasma physics, specialization plasma physics. Thank you. Thank you, Dr. Mashek. And now time has come to present my review, and I fully agree with the previous speakers. So I'll focus on the comments. I have two questions. My questions are of general nature. The author describes discharge plasma in argon in non-local approximation. Yet to address this task in the thesis to calculate non-local EDF, the author uses a popular software and codes for local Boltzmann equation. Is this not contradiction? And the author also mentions a Holstein-Zendin method. Is this a common term? Now, please answer all the questions, and you have, please. First of all, thank you. Dear council members, for giving your time to reading and giving your comments, which I will certainly take into account in my future research. I will start with questions of Dr. Wang. First and second comments about synonyms, non-equilibrium, disequilibrium, etc. I agree. And the second comment that some pages, on page 65, the description is in Russian. And the third comment is that comment is about Holstein-Zendin method. Is this a common term, and why I call my method like this? So as a second comment, I agree with Dr. Wang. There are some misprints, and I will try to avoid them in the future. As for the third question, the method was named after Holstein-Zendin, because historical Holstein was first to note that the Boltzmann non-local equation can be simplified by introducing the full energy, and later Zendin in the USSR also introduced approximation, the concept of approximation, developed in his works, which made a significant contribution to the development of non-local kinetics. The term has not been previously used in literature. It was introduced by my supervisor and a student of Zendin. And priority of Holstein-Zendin is obvious in the development of non-local kinetics. We hope that the term we propose, will be used by other authors in research on kinetics of electrons. And comments by Timofeev Nikolai Alexandrovich. As for the first comment, yes, I agree that there is a contradiction, that practically all modern software packages and codes solve the Boltzmann equation in local approximation when it rejects all the terms with spatial members, and it becomes one-dimensional, depending only on the kinetic energy. However, in a general case, it's necessary to solve the equation in variables of both energy and coordinates. And in the pioneer works, Holstein and Sendin have shown that the non-local kinetic equation, by replacing the variables from kinetic to total energy, can be reduced to one-dimensional, depending not only on the total energy. It will look similar to local approximation, only with averaged coefficients. Therefore, having performed the averaging procedure, we can further use any available code to solve the Boltzmann local equation. And as for the second comment, it's quite similar to the previous comment, and I would like to emphasize once again that this is not a common term, unfortunately, but we hope that we will be the pioneers. And well, these two scientists, Holstein and Sendin, deserve this method to be called after them. As for the comments of Dr. Smirnov, about the information of EFD, the main thing for us was to compare the EFD found in the traditional local approximation with the non-local EFD. Therefore, we used the comparison of modeling results in closest conditions. As for available experimental data for the positive column in argon, in literature of measurements of EFD, the required spatial resolution is not enough and accuracy is insufficient for a real comparison. So we already started work to compare the results. As for the second remark, we didn't speak about constrained conditions. The object of our research was a classical positive discharge column in a cylindrical tube. So the conditions were quite standard, zero on the wall and symmetry on the axis. As for the third comment, we thought about it when we started at the initial stage. But then we decided the criterion proposed by us seems to be more convenient, and in our future research we will try to use the advice of the reviewer. And as for comments of Dr. Rajansky, for the first remark, it's quite similar to previous reviewer. And I would also like to say that we have planned to do such work in the future. So we're going to make comparison not only with the model and results, but also with the experiment. And as for the second remark, as for potential profile, the solution for balance plasma concentration for direct ionization and is Bessel function, and many researchers have proved that this approach is a good approximation for more complex conditions of diffusion profile. So for approximation, we used Bessel profile of electron concentration. At present, we have already started working on modeling of a new model, and so we will clarify our results. Preliminary results show that diffusion on the plasma profiles decline slowly and agree well with Bessel. And as for the common Celine, so we agree with the reviewer that non-local EDF transport coefficient differ from those found in local approximation. Partly these results used in our work comparing the mobility of electron gas in argon. We thank the reviewer for the importance of knowing the effective transport coefficients, and we'll try to analyze this issue in more detail in our future studies. And as for the question of Igor Vyacheslavich Mashek about discharge geometry, forget geometry, how sustainable will your solutions? Unfortunately, so far we have not been able to compare, so we have not solved the problem yet. But of course, in the future, parameters will do so, and parameters will be different if we change geometry, because profiles depend on the spatial distribution. Well, the first step can be very easy. You can do exactly what you have done already, but with different entry parameters. That will show how reliable your results are. Thank you for this comment. Hopefully in the future we shall do so. And well, this is an interesting task. And in conclusion, I would like to It's too early. Dear colleagues, are you satisfied with the answers? Professor Wang, are you satisfied with the answers?
Yes. Yes.
Okay, thank you.
No, I can't.
Unfortunately, we don't have the academic advisor with us. Academic advisor is absent, and the review is as follows. Rabadanov Kurban Magomedovich has completed a master's course in the Department of Optics of St. Petersburg University in 2015. Under supervision of Professor Golubovsky, entered the postdoctoral course under Professor Kudryavsky. During his master's course, he studied non-local electron kinetics. When he applied for his postdoctoral course, he decided to continue his master's. He started as master's student. He studied non-local electron kinetics. Investigated by Professor Kudryavtsev, Professor Kudryavtsev. While he was a student, he demonstrated his ability to work independently, took part in scientific conferences. Relevance of the theme of his study is that new devices call for a need to analyze processes more carefully. The thesis by Mr. Rabadanov is dedicated to non-local distribution of electrons and to clarification of conditions of non-local electron distribution for modeling physical processes with the help of modern software packages. The thesis contains some interesting results on electron distributions, which are can be key to understanding gas discharge. The results have been published in several journals and presented at international conferences. Validity of his research is obvious, and as a result, we may say that Mr. Rabadanov deserves the degree of candidate of physics and mathematics, specialization. Well, dear colleagues, dear guests, now we must discuss the results of all the presentations. So you are kindly requested to leave the room, and I will invite you to come back. First, let me start with the formal part. Let me remind everybody that a decision of the Dissertation Council will be considered positive if more than a half, but not less than 3 members of the Council taking part in the session voted for it in accordance with Article 23 of the procedure for awarding academic degrees at St. Petersburg University. Let's start voting. Igor Chislavovich, your opinion. I support awarding the degree to the candidate. Dr. Rozhansky Vladimir Alexandrovich, I am for awarding the degree. Dr. Smirnov, Professor Van, what's your opinion? Do you support?
Yes, I support.
Да, я поддерживаю. And myself, as a chairman, I also agree that the work deserves a degree of candidate of physics and mathematics, specialty plasma physics. Was, dear colleagues and guests, out of 5 members of the Council, 5 voted for, no one voted against, and no one abstained. So before the chairman would always congratulate immediately. So we all congratulate the candidate, but according to the new procedure, finally you have this is time for your final word. First of all, I would like to thank dear council members for all their comments It's very important to see your positive and negative points, and I would like to thank all the members for giving their time to come to this session. I would like to thank Dr. Kudryavtsev for his guidance and for all the assistance he has given me, and I would also like to thank Bogdanov Evgeny Anatolyevich, who also assisted me with interpreting results and working on my thesis. I'd like to thank my first academic advisor, Dabowski. I started developed this entrance under his guidance. I'd like to thank all the council members. Thank you. Thank you, Kurban Magomedovich. I declare the session closed. Please stop the online broadcasting. Thank you.